Hey everyone, just wanted to do a quick review for you before we get into the operations with radicals. So this is a review of simplifying those. So when we are simplifying radicals, we want to find the prime factorization of what we are trying to simplify. So we want to find the prime factorization of that. So there's two ways to do it. So we could use a factor tree or inverted division, or my kids call it the birthday cake method. So if we're going to do the factor tree, let's start with that one. So here I can pick any two factors that I know will multiply together to give me 512. So I'm going to use 4 and 128. 4 is not prime, so I'm going to break that down into 2 times 2. These are prime, so I'm going to circle those. 128 is not prime, so I am going to break that down into 2 factors. So I'm going to use 4 and 32. 4 break down into 2 and 2. Those are prime. 32, I'm going to use 4 and 8. And again, you could use any factors here as long as they give you that number. 4 is going to be 2 and 2. 8, 4 and 2, and 2 and 2. So the prime factorization of 512 is 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. So I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's using the factor tree. The inverted division or the birthday cake method, I actually like this one better. I think it's quicker, but you guys can use whatever you want. So the only thing that you need to remember with this is this outside number has got to be a prime number. So 2 I know is prime, and this is even, so I know 2 will divide into it evenly. So 512 divided by 2 is going to give us 256, I believe. Let me check on my calculator, make sure I'm doing it right. Yep, 256. Then this is even, so I need a prime number here. Divide evenly. 256 divided by 2 is going to give us 128. Again, this is even, so I'm going to draw another division sign. Divide it by 2 because I know 2 is prime and that's even. So 128 divided by 2 is going to give us 64. Here, 64, I know 2 is prime, and that's divisible because it's even, so that's going to give me 32. And I can keep dividing by 2 because 2 is a prime number, so that's going to be 8. That's going to be 2 and 4, and that's going to be 2 and 2. So here, my outside numbers will list my prime factorization. So 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. So we get the same answer no matter which one you do. Now, because we're finding the square root, we need to find pairs. So when we're finding pairs, here's a pair, here's a pair, here's a pair, and here's a pair. So because this counts as one pair of twos, that's 2, times this counts as one pair of twos, so that's 2, times this counts as a pair of twos, so that's 2. This counts as a pair of twos, so that's 2. So I want to just multiply those together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is the product of these. This goes on the outside of the radical. The number that is left over goes on the inside